Hello students, welcome to aimsindia online classes. This is a chemistry session. Here we are discussing about chapter water. In the earlier sessions we have seen different concepts related to water, like how water is available to us, in how many states it is available, and even what are the different forms of water, like pollution of water, how to purify water, isn't it? We have seen these all concepts. Now, in this session, we are going to see about the properties and the uses of water. Okay, let us see about the properties and the uses of water here. First, let us go through the properties of water. Physical properties of water, let us see first. What is the color of water? Have you seen our pure water? We know pure water is a colorless, odorless, and a tasteless liquid. But deep water bodies like ponds, lakes, rivers, they appear greenish blue due to the scattering of light. Actually, if you say pure water has no color. Not only color, they do not have any odor and taste also. But you may get one question, that is the water which we drink will be having slight taste. That is because of the dissolved salts and gases in the water. That water which is suitable for drinking contains certain dissolved gases and salts in it. That is called mineral water. Because of the presence of these minerals and gases in the water, it gets certain taste. That water is suitable for drinking. That is called potable water. But if we take pure water, generally we can say distilled water or rainwater. These are pure forms of water, we can say, isn't it? Naturally occurring pure water is rainwater, and prepared in the laboratory, purest form is distilled water. In these two, water is containing no impurities in it, no other substances in it. In that state, water will be having no color, no odor, and no taste also. Okay, that is a property of pure water. But in the water bodies, if you see like rivers, ponds, lakes, and oceans, water seems to be light blue color, isn't it? In light greenish blue color, it seems. Yes, this is because of the scattering of light, but it is not the original color of water. Okay. Next, another property: boiling point of water. What is meant by boiling point? First of all, boiling point means the temperature at which a liquid starts converting into its a vapor form or gaseous form. The boiling point of pure water is a 100 degrees Celsius temperature under normal atmospheric pressure. Of course, the boiling point of water gets elevated, means it may increase due to the presence of soluble impurities in the water. But pure water boils exactly at it starts boiling exactly at 100 degrees Celsius temperature at a normal pressure or atmospheric pressure. Atmospheric pressure means that is 76 centimeters of Hg or mercury, or 760 mm of Hg, which is also considered as 1 atmosphere pressure. At this pressure, pure water starts boiling at 100 degrees Celsius. So pure substances generally they will be having sharp boiling points. So pure water has its boiling point at 100 degrees Celsius temperature. But sometimes it might be observed in the laboratory, the boiling point of water will be increased. It will be above 100 degrees Celsius. This is just because of the presence of dissolved impurities in the water, like certain salts and some other gases presence. So the presence of these salts and gases increases the boiling point of water. Otherwise, if it is pure water, its boiling point is fixed and it is equal to 100 degrees Celsius temperature. Okay. Next, melting point of ice or freezing point of water. Generally, these two will be same for any substance. Melting point and freezing point. What is meant by melting point? Melting means we know the conversion of a solid into liquid. Melting point means the temperature at which a solid starts converting into its liquid form is called its melting point. In the same way, freezing point, freezing means the conversion of a liquid into its solid form on cooling is called freezing. And the temperature at which a liquid starts converting into solid form is called its freezing point. Generally, for the substances, melting point and freezing point both will be same. Now, here the melting point of ice or the freezing point of water will be at 0 degrees Celsius temperature. That means at 0 degrees Celsius, ice starts converting into water form. Or if you take water, if you start cooling it, after coming to 0 degrees Celsius temperature, it starts converting into ice form. That is a freezing point. So the melting point or freezing point of water is 0 degrees Celsius temperature. Ice melts and water freezes at 0 degrees Celsius at normal pressure, normal atmospheric pressure, that is 1 atmosphere pressure. That means pure water freezes at 0 degrees Celsius at 760 mm of Hg pressure. Okay, now we can say pure water has boiling point at 100 degrees Celsius temperature and melting point at 0 degrees Celsius temperature. Next, density of water. The maximum density of water is 1 gram per cubic centimeter and it is obtained at 4 degrees Celsius temperature. That means the density of water increases with increase in temperature up to 4 degrees Celsius. So water has its maximum density at 4 degrees. On increase in temperature above 4 degrees, density slowly decreases. And even after cooling temperature below 4 degrees also, its density gradually decreases. Because of this reason only, ice has less density than that of water. That's why we know ice floats on water. Even though if you take very heavy ice cubes, if you throw them into water, they start floating. They start floating, isn't it? Why? Because ice has less density than water. Water has its maximum density at 4 degrees Celsius temperature. So if we cool water further to make water into ice, what we have to do? We have to cool that water below 0 degrees Celsius. That means we are cooling the water below 4 degrees. When the temperature decreases below 4, the density of water slowly decreases. When it converts into ice, the density of ice will be less than that of water. That is why only ice floats on water. Okay. Next, conductivity of water. Pure water is a bad conductor of heat and electricity. The electrical conductivity of water is due to the presence of dissolved salts in water. Actually, if you take pure water cannot conduct electricity. But the water which we use generally in our daily life, if you keep electrodes into that, that water can conduct electricity. This electrical conductivity of that water is because of the presence of dissolved salts and gases in it. So because of the dissolved salts, there exist certain ions in the water. So as ions are present in the water, that water can conduct electricity. So the water which we drink and the water which we use in our homes, which comes through the taps and bores, that contains already certain dissolved salts in that, certain minerals in that. So because of the presence of these minerals, that water can conduct electricity. But actually, pure water is a bad conductor of electricity. Water cannot conduct electricity through that if it is pure. So certain water which you use daily that may conduct electricity because of the presence of salts in it. But water is a pure bad conductor of electricity. Okay. water cannot conduct electricity. But we say in lower classes in the earlier sessions we have seen electrolysis of water one experiment. There, as water is a bad conductor of electricity, to conduct electricity to water, there we add a small quantity of salt or acid to the water. Did you remember this? So the water which is added with the acids, certain quantity of acid is called acidulated water. So in the electrolysis process, it was used acidulated water but not pure water, because pure water is a bad conductor of electricity. To make it good conductor, small quantity of acid is added. That added water is called acidulated water. Because of that acid or minerals, that water can conduct electricity. Okay. Next, specific heat capacity. This is defined as the amount of heat energy required to raise the temperature of 1 unit mass of substance through 1 degree Celsius temperature or 1 Kelvin temperature is called specific heat capacity of that substance. So what it is? Specific heat capacity means the amount of heat energy required to increase the temperature of 1 unit mass of a substance by 1 degree Celsius or 1 Kelvin temperature is called its specific heat capacity. So for water also there is specific heat capacity. The specific heat capacity of water, pure water, is 1 calorie per gram per degree Celsius. Means if we take 1 gram of water, to increase its temperature by 1 degree, it requires 1 calorie of energy. That amount of energy required to increase the temperature by 1 degree for 1 unit of substance is called its specific heat capacity. So for water, the calorific value is the specific heat capacity is 1 calorie. Means for 1 gram of water, to increase its temperature by 1 degree Celsius, it requires 1 calorie of energy. So this also can be given in other units like this: 4.2 joules per gram per degree Celsius. So to increase the temperature of 1 gram of water by 1 degree Celsius, it requires 1 calorie of energy or 4.2 joules of energy. So this is a highest specific heat capacity among all the other substances. It requires a very large amount of energy to increase its temperature. That means the specific heat capacity of water is highest among all the substances. Next one, another property is latent heat of vaporization. The amount of heat required to change 1 gram of water at 100 degrees Celsius temperature into steam at the same temperature is called latent heat of vaporization. It means if we take water in the liquid form, if we start heating that water by keeping a thermometer in that bowl, if we observe, then slowly the temperature of water rises on heating continuously. Once the temperature of water reaches 100 degrees Celsius, then we know the boiling point of water is 100 degrees. Then water starts boiling and converting into vapor form. Then if you observe the thermometer, then there will be no increase in the temperature reading. It will be maintained at 100 degrees Celsius only. Even though if you continue heating, then where that heat is going on, where it is being disappeared, there the heat energy given to the water is utilized by it to convert into gaseous form, to be converted into vapor form. There the amount of energy required to convert liquid into gas is called latent heat of vaporization. Here the latent meaning is hidden, that hidden heat energy which is used by that liquid to convert into gaseous form is called latent heat of vaporization. It can be defined as the amount of heat energy required to change 1 gram of water into 100 into steam at 100 degrees Celsius is called latent heat of vaporization of water. Its value is 2260 joules per gram or 540 calories per gram. That is why steam causes far more serious burns than water. See, so by giving this much huge amount of energy, water converts into steam. So steam has more energy, more heat energy in that. That's why only steam causes severe burns than the hot water, isn't it? So that is about latent heat of vaporization. The amount of heat energy required by water to convert into steam is called latent heat of vaporization. Its value is equal to 540 calories per gram. That means to convert 1 gram of water into steam at 100 degrees Celsius temperature, it requires 540 calories of energy or 2260 joules of energy. By supplying this much amount of energy only, 1 gram of water converts into vapor at the same temperature. Okay, without change in temperature, just it converts into gases formed from liquid state. That's why that steam will be having more heat energy. It will be more hotter than hot water. That's why if you touch a steam, it causes severe burns than the hot water. Next property is latent heat of solidification. What is meant by solidification? Conversion of a liquid into solid form is called solidification, which is also called as freezing. It is defined as the amount of heat energy liberated by 1 gram of water at 0 degrees Celsius to form 1 gram of ice. At 0 degrees Celsius is called specific latent heat of solidification. Latent means we told hidden. So as we told in the earlier case, here also if we take certain water, if we start cooling, if you observe the temperature of water by inserting one thermometer, as we start cooling, the temperature reading will be slowly comes down. But after reaching once the 0 degrees Celsius temperature, then water starts converting into ice form because we know the melting or freezing point of water is 0 degrees. So there, even though if you continue cooling, the temperature reading in the thermometer won't be changed. Then water starts converting into freezing form. So there, the heat energy liberated, that heat energy liberated by water in converting into ice is called latent heat of solidification. The amount of energy liberated by 1 gram of water while converting into ice. We know any system will release energy while solidifying. Any liquid will release out energy while solidifying. And any liquid will absorb heat energy while converting into vapor form. Here, while converting into ice form, water slowly releases its energy out. The amount of energy liberated by water while converting into ice at the same 0 degrees Celsius temperature is called latent heat of solidification. Okay, the latent heat of solidification for water is 336 joules per gram or 80 calories per gram. Means 1 gram of water releases out 80 calories of energy while converting into ice form. Okay, that is about latent heat of solidification. Okay, it is on account of high specific latent heat of solidification that lakes and rivers do not freeze suddenly. That's why only these lakes and rivers, they do not freeze suddenly in the winter season because there the upper layers of lakes and rivers, they start converting into ice form. While converting like that, they release a high amount of energy into the water. Because of the existence of that energy in the water, the lower layers of water, they still maintained in the liquid state only. So because of this, only upper layers of water will be converted into ice form and it covers under the layers will be in the liquid form still. Because of this reason only, these aquatic animals are able to survive in the water even in the winter season. Because only upper portion of water will be solidified. Under that, water will be in the liquid form still. So in that water, these aquatic animals will be living. Okay. Next, let us see here test for water. How do we test this water? If we take a glass of pure water, it seems with no color, no taste, and no odor. In our homes only will be having water. We can say immediately as it is water if you see that. But if you go ever to a laboratory, there we can see so many liquids just like the water, which seems like water. They will also will be with the no color, transparent liquid. So many will be there. But all we cannot expect as water. But we cannot taste them too. So then we have to use some techniques for testing those liquids, whether it is water or not. Let us see here some general tests for water. One of them is general test. It is pure water is colorless, tasteless, and odorless liquid. Okay, we know pure water has no color, no taste, and no odor. But the drinking water or potable water has certain taste and a luster. This is because of the presence of dissolved gases and minerals in the water. But if it is pure water, it has no color, no taste, and even no odor also. Okay, let us one more test. And we told at the starting here, pure substances they have sharp boiling and melting points. Even pure water also have its boiling point exactly at 100 degrees Celsius, and even its melting point or its freezing point is exactly at 0 degrees Celsius. These two are fixed for the pure water. So they will be very sharp if for the pure water. But if it is having any impurities in it, then these will be varied. So if water starts boiling at exactly at 100 degrees Celsius, then we can say that is pure water. If it freezes exactly, if it starts freezing at exactly at 0 degrees Celsius, then we can say that is pure water. These are general tests. But all the chemicals we cannot taste and we cannot smell in the laboratory because they may cause harm to us. Then we can use another test for testing this water. Let us see that here. That is, when a drop of water is poured over anhydrous copper sulfate. Anhydrous copper sulfate means the copper sulfate substance without water. Actually, it will be in the white color. When water is added to it, then it turns to blue color due to the formation of hydrated copper sulfate. Hydrated copper sulfate means in that copper sulfate molecules will be combined with the water molecules. Then that is called hydrated copper sulfate. Hydrated copper sulfate is having blue color. So, but without water molecules, that is called anhydrous copper sulfate. It will be in the white color. See, it is shown here. Anhydrous copper sulfate has no color. If one drop of water is added, immediately it turns into blue color. So this blue color is because of the formation of hydrated copper sulfate, which is having blue color. Okay, this is one of the tests for testing water. Whether the given colorless liquid is water or not, we can test with this anhydrous copper sulfate. If you add a given liquid to that one drop to that copper sulfate, anhydrous copper sulfate, if it turns to blue color, we can say the liquid given to us is water. Okay, these are the test for water. Now let us see here the uses of water. Is water useful to us? Of course, in many ways. Let us see where the water is used generally. First, uses in daily life process. Water is used for drinking process. It helps in dissolving of food materials in our digestive system. Okay, which are then assimilated by our body cells. Yes, mainly for the digestion of food, and not only for the digestion of food, in many metabolic processes, water is very important. Okay, in the dissolution of food materials in the digestive system, water is very helpful. It also helps in the excretion of waste materials from our body. Yes, water is also used in the excretion of waste materials from our body, like sweating and in the other process. Okay. Next, water regulates our body temperature by the process of sweating and evaporation. So by sweating and evaporation process, water regulates our human body temperature. It's very important there, isn't it? So in this way, water is very useful in life processes. Next, the uses of water in agriculture. Water helps in dissolving nutrients present in the soil, which are assimilated by the plant roots for the manufacturing of food. So what happens if water is given to the crops? The water dissolves nutrients present in the soil. So that water will be taken by the plants through their roots, and this water is used in the manufacturing of food by the plants and for their growth and development. So in that way, this water helps the plants in taking the nutrients from the soil. Not only there, various kinds of insecticides are dissolved in the water for spraying on the plants to kill these insects and dissolve, and even certain fertilizers also. They are dissolved in the water and they are sprayed on the plants. In that way also, water is useful in the agricultural process. Okay. Uses of water in generation of electricity. Yes, water is used in the production of electricity also. That we say hydroelectricity. At the hydroelectric stations, water is used to drive the dynamos, which in turn generate electric current. There in the hydroelectric power stations, water is used for the driving of these dynamos, for the rotation of these dynamos, from where the electricity is produced. Not only there, even at thermoelectric power stations also, water is changed to steam by heating. The steam is then used to drive dynamos to generate electric power. Okay, in this way, even in the hydraulic power stations, even in the thermoelectric power stations also, water is used. There in the hydraulic stations, directly water is used to drive the dynamos. So while these dynamos are driven, they produce electrical energy. And in thermoelectric power stations, first water is converted into steam. That steam used to drive the dynamos from where electricity is produced. Okay, in that way, water is used in the production of electricity. And the use of water in the industries. Water is used in large number of industries such as dyeing industry, tanning industry, steel industry, alcohol industry, etc. In many industries, this water is used. And the use of water in the manufacturing of chemicals. Water can be broken into hydrogen and oxygen by chemical process, that we say electrochemical process or electrolysis of water. Just now you told no. By the electrolysis of water, what happens? Water decomposes into hydrogen and oxygen gases. The hydrogen and oxygen gas are raw materials for the manufacturing of so many chemicals such as ammonia, nitric acid, hydrochloric acid, etc. These all chemicals are prepared from either hydrogen or oxygen. So these hydrogen and oxygen are derived from water by the process called electrolysis. Electrolysis. Electro means current. Lysis means the splitting of the molecules. So by passing electricity through water, it is a splitting into hydrogen and oxygen. These two gases are used for the production of so many chemicals. Okay, that is a use of water in the production of chemicals. Okay, those are the different uses of water. Thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates and recorded videos.